In problem number 7, we're going to be using Ohm's law. You like Ohm? Okay, so Ohm's law, V is equal to IR. And we're also told, suppose V is increasing at a rate of 1 volt per second. Now I read it out loud, and now I need to translate that into mathematical notation. Imagine, or say, suppose that V is increasing at a rate of 1 volt per second. That translates in my mind to dV dt is equal to 1. Or 1 volt per second. That's supposed to be an S. Suppose I is decreasing at a rate of 1/3 amp per second. I is changing, the change in I with respect to time is 1/3, and I guess that would be in amps per second.
Is it negative?
And it's negative because it's decreasing. All right. And all of our times are in T. Oh, I guess we already answered A. I guess we already answered D. And now, write an equation that relates dr, dt, dv dt, and di dt. Okay, here we go. I'm going to start with Ohm's law. And like we did in all the problems yesterday, we're going to take the derivative of both sides of this with respect to t. Alright? The left-hand side I think is trivial. The derivative with respect to time of volts is dV dt. The right-hand side, not so trivial, because we have I and R, and both of them are variables. Not only both of them are variables, but both of them are assumed to be or implied to be functions of time. So when we take the derivative of that, it's not a variable times a constant, or a variable times a variable, it's two functions. So how do we take the derivative of two functions multiplied together? Give me a P. Give me an R.
Product rule.
I guess, yeah, that would have been long-winded if I was like, yeah, we're going to use the product rule. Okay? So, product rule. First times the derivative of the second. Plus the second times the derivative of the first. So funny, I've got so many different books open the same. All right, and that's what they wanted. They wanted what is the relationship between dV dt, dr dt, and di dt. That's it. So there's C. Good? Okay, that was number 7.